Hello everyone and welcome to creating Minecraft from scratch, new series where we'll be using Unity 3D and C# and Microsoft's ASP.NET to create a game client and server for Minecraft. If you're interested in following along, there's a repository here, github.com/retrobytes/minecrunch, that you can follow along. I'll be putting every episode's source code on a branch. So you will look for episode 1, obviously once I've uploaded it, if you want to have a look at the code. Alright, so here I am in Visual Studio. I've got Visual Studio 2017 Community. I've already created the solution. I've called it minecrunch.libraries. And I've already added some of the models that we'll use that will define our world for terrain generation anyway. We're going to start with terrain generation. The solution is completely separate from Unity because these models will actually end up in a DLL file that will be shared by the server and the client so that they both have a common understanding of the models that make up the game. So I'll just go ahead and I'll start here at the beginning. So I started by defining what a block is to the game. So just clean up some code here. The block class is first and foremost serializable. So what that means is that when we go and we create a lot of these blocks on the server, we're going to want to be able to turn that into a compressed data stream so that we can send it over the internet to the client. And that process of turning a model or an instance of a class in C# into a stream of data is called serializing. And then on the other end, obviously the game client is going to deserialize the data back into something that the game can understand. So that's first and foremost. Almost all of the models that we're creating today are serializable because we have the intention of being able to transfer them over the wire or back and forth between the server and the client. With the context of the block in mind, we want the block to store its X, Y, and Z position inside of a chunk, but not actually like the world position, just the position of it inside the chunk. Alright, the next bit of data that we're going to have about our chunk is the ID of it. So is it a grass block? Is it stone? Is it dirt? Is it air? Is it water? Early versions of Minecraft stored this as like an integer, which is why it was called ID, I guess. I don't know. It made more sense, I think, to store them as numbers. It's easier to serialize and deserialize. It takes up less space, but later Minecraft updated it so that it kind of looks like this now, I think, right? So now IDs are no longer 0, they're now a string. So I'm going to do the same thing here, where our ID for blocks is going to be a string. The next is a little more complicated. So this is a byte that represents the visible faces on a block. And you can see I'm initializing that byte here to all zeros. Here is under sides, which is the next file. Here's an enumeration that kind of illustrates what each bit inside of that byte means. So a 1 is visible, a 0 is invisible. So what does that byte look like if just the back is visible? Well, here's what it looks like if just the back is visible. And all the way down. So you can see that we're wasting 2 bits but that's okay. Maybe we'll find something else to use those 2 bits for later. And then I created some helper methods. These perform some Boolean logic to set the face as visible or invisible, and then to get whether a certain face of a block is visible or invisible. This is important later when we go to actually rendering the chunk. We don't want to render block faces that aren't currently visible. Okay, so that is the model for a block in our game. So moving on, the next thing is a chunk. So the chunks in Minecraft are actually broken down into sections, where vertically there are 16 sections of a chunk. And that works out nicely because then each section ends up being 16 by 16 by 16 blocks. And you can see that that's actually how we do the block array inside of a chunk section. So each chunk section is responsible for retaining 16 by 16 by 16 blocks. And then a chunk itself has 16 chunk sections. So I'm going to jump back over here to chunk sections. Other information that we need to store about the chunk section is what its number is. So this will be a number between 0 and 15. Since there are 16 chunks, but computers start counting at 0, it'll be 0 to 15. And then I've added a helper method, which we can use to ask for all of the blocks, but not in a 3D array, in a list, a C# list. So this just casts that block array to a list and returns it to anyone who uses it. That's useful later when we start doing terrain generation. We'll end up using that method. Let's see, other information, so we're moving on to chunks now. Other information is the chunk we need to know, like its X and Y coordinates in the world. So the chunks, if you're looking top down at Minecraft, are laid out in an X and Y pattern. We need to keep a timestamp of the last time the chunk was updated. This is so that the client and the server can stay synchronized and be in agreement about the state of a chunk. And then finally here we need a 2D array of the surface blocks for a chunk. And we store this information as a double, which is to say it's a number that has decimal places, because the noise generator that returns the surface of our world was actually going to give us decimal places, and then we make a determination what that translates to as an integer. So we're going to store that double in a 2D array. So this basically says for any X and Z inside of a chunk, return the Y value to me to tell me how tall the surface is, or rather where the surface of the map is. Other information, we need to keep track of our sections. Each chunk is going to own 16 sections, so we've got an array of 16 sections. And then helper methods. So here's a helper method to get a block by a chunk coordinate. So one of the issues is that the chunk doesn't actually own the blocks. Like, block is nowhere up here. In order for someone to say, I'm in this chunk, give me this block because I've created it or I've destroyed it or whatever else, the chunk needs to go look at its sections, because the sections are the ones that hold the actual blocks. So I wrote a helper method called get block by chunk coordinate, and it takes in an x, y, and a z. And what's important is that these are coordinates within the chunk, not the coordinates in the world that we're maybe used to seeing. So the caller will be responsible for returning us values for x, y, and z, where x and z are between 0 and 15, and y is between 0 and 225. And then, I do some logic here to sanity check and make sure that they're actually returning us values that make sense. So x can't be greater than 15 and z can't be greater than 15. One caveat with this is that when we actually get to start generating chunks, to save space and to save time, we're not going to actually generate sections that are just full of air. And furthermore, we're not actually going to generate blocks that are just air. I know that Minecraft has an actual block ID for air, but for me, what that would mean is that I need to actually save that block in, a data stream. But I can save a lot of data and a lot of processing time if I just don't save air at all. So I don't save air, and I don't save chunks that are just full of air. Imagine a player that's just nerd pulling up into the sky. Every time he enters a new section, that section's not going to exist yet. So for the get block by chunk coordinate, we put in some null coalescing. So what this says is if the section that they're asking for a block for, if that section doesn't exist, return null. That's what this question mark does. And then if it does exist, if that block is null, return null. So this is if block exists or if it's null. And then similarly down here in set block, we check if this section is null, and if it is null, then we need to go ahead and create a new section so that we can store that block into that section. All right, and then I've added this same helper method called get all blocks, because this will be useful in the future when we get to terrain generation. All right, so that wraps up this series, or this episode. We've, in this episode, generated models that represent our chunk sections, and the blocks that are inside of those chunks, as well as created an enumeration so that we can use bytes to store which sides of our blocks are visible. All of this is leading us down the path of creating meshes, which you can kind of see here. I've cheated on and started early, but we'll get back to that in the next episode, episode 2. So I hope to see you all then.